In this lecture, we try to differentiate and integrate the error function with the example so that derivative of error function of ax is given by 2a divided by root pi whole multiplied by e to the power minus a square x square, and also evaluate integration of error function of ax under the limit 0 to t with respect to x. We know that error function of x is given by error function of x is equal to 2 upon root pi under the limit 0 to x of e to the power minus u square du. Let us consider if we replace x by ax, then this will error function of ax is equal to 2 upon root pi 0 to ax. Only this part will change. The limit will be 0 to x will become 0 to ax e to the power minus u square du. Using DUIS rule, because if you want to differentiate it, since this is not possible to integrate e to the power minus u square, so what we will do, we apply the DUIS rule, rule number 2. Why? Because if you want to differentiate with respect to x, the upper limit of the given integration is function of x. So we know that error function of d is using di. We know that DUIS rule means differentiation under integral sign. Rule number 2 is what? Derivative of error function of ax, which is given by 2 upon root pi. We are taking this outside, and then integration under the limit 0 to x, derivative of e to the power minus u square with respect to x, because we want to differentiate with respect to x. And since inside there are this e to the power minus u square is not the function of x, we are using the partial derivative with respect to u plus derivative of upper limit, derivative of upper limit with respect to x. So upper limit is what? It is ax, and the value of the function at u is equal to upper limit. What is u is equal to upper limit? It is u is equal to ax. So let us just put u is equal to ax, so e to the power minus a square x square minus derivative of lower limit. So lower limit is 0. So derivative of 0 with respect to x, and the functional value of the function e to the power minus u square at lower limit, which is 0. So we have to put e to the power 0. I think this is clear to everyone. Uh, Integration, we are using the DOIS rule. So inside the integration we are using, and since the limit is not constant, so we are using these two things for based on the upper limit and lower limit. Now if you simplify it, since this is the e to the power minus u square, which is free from x, so partial derivative of e to the power minus u square will be 0, and derivative of ax with respect to x is nothing but a into e to the power minus a square x square, and again derivative of 0 with respect to x is also 0. This two thing will be 0. So now we have 2a e to the power minus a square x square upon root pi. This is the derivative of error function of ax, which is given by 2a into e to the power minus a square x square upon root pi. Now this gives our first result. Let us try to evaluate the integration of error function of ax under the limit 0 to t. Consider, since we don't know what is the integration of error function, so we just treat this error function of ax as one function, and we introduce multiply by 1, and we use the integration by part. So if we apply the integration by part, the first function, so we don't know what is the integration of this, so we will take this is our first function. So integration of 1 is x into first function into second function, which is error function of x under the limit 0 to t minus derivative of first function, which is error function of x into integration of 1, which is x, and whole integration. This is what it is, differentiation under integral sign. Integral integration by parts, sorry. We know that what is that? uv dx is equal to u integration of v dx minus integration of d dx of u integration of v dx and whole dx. This is we know about it. It is the integration by part. So we applied over here. We have taken u1 is u and error function of ax is v. If we simplify it, if you put the limit, so this x will be t, error function of at, minus if you put the lower limit, so if you put x equal to 0, this will become 0, minus 1 upon, now we know what is the derivative of error function of ax. Just in the previous slide, its value is 2a into e to the power minus a square upon a square x square upon root pi, and x dx. Now we are doing some adjustment over here because we want to integrate this whole term. So what we have done, we are multiplying and dividing by, this is 2a e to the power minus a square x square upon root pi. Now if we differentiate this part, minus a square x square minus a square x square, with respect to x, its value is 2a square x minus 2a square x. So we are multiplying this minus 2a square x with respect to x. So now x is already over here. X is over here. A is already over here. A is already over here. So we are multiplying and dividing by a. So this is a square. 2 is already over here. Minus and minus is already over here. So actually this is not over here. We have this 2a we have taken over here. X is we have taken. So root pi something upon e to the power minus a square upon x square. Root pi we have also taken outside. Okay, is it clear, everyone? We 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 have, this is 2a. This 2a is over there, and since we are again we want one more a, so we have divided and multiplied by a. X is already over here, and this we have taken this side. Let us go ahead. So the first part is t, error function of at, plus, just look here, 1 upon a root pi, and this is nothing but e to the power minus t. E to the power minus t, what is the integration of e to the power minus t? E to the power minus t up into minus 1. So this minus and minus will become plus, right? And since it is the derivative, so if we put like this, just let me just show you. If we put here, this 2a is not over there. This pi we have already taken over here. So we want to find out the integration of e to the power minus a square x square minus 2a square x dx. So if you put a square x square equal to t, then minus 2a square x dx is equal to dt. Right, and limit will not change because this is the uh, algebraic function, so limit will not change. It will be 0 to infinity. So this is what it is, nothing but error function of f of x f dash of x dx is equal to e to the power f of x. So if you put the upper limit and lower limit over here, t into error function of f of t plus 1 upon a root pi e to the power minus a square x square. So if you put the upper limit, it will become e to the power minus a square t square minus error function of 0 is 1. So therefore, the integration of error function of ax with respect to x under the limit 0 to t, which is equal to t times of error function of at plus 1 upon a root pi into e to the power minus a square t square minus 1. So please note at this point, this 2a is we have already adjusted over there. So there is no 2a over here. This pi also we have taken in this part. So just we have to take this is t and this is nothing but dt. Thank you.